let's start with number 3. We just want to simplify the square root of 28. All right. And the key thing here is that it's not a fraction. So we're not going to use that fractional property. We're going to use the property of a product of numbers. We're going to split this into a product of numbers, something times something else, so that when we split them up, it'll get simplified. So let me show you what I mean. How about if we do 4 times 7? 4 times 7 is 28. And that property that I'm talking about is one where we can split up the square root of 4 and the square root of 7. Square root of 4 times the square root of 7 is the same as the square root of 28. And the square root of 4 is a perfect, not a perfect, a whole number. And so 2 times the square root of 7. So now that's simplified form of the square root of 28. Let's look at number 4. The square root of 192. Alright, so if we're just starting out with this, we're going to look to split this up so that when we split it up, one of the square roots has a whole number as its square root, right? We want the square root of 4, we want the square root of 9, or the square root of 16. We don't want to wind up with two square roots that aren't perfect squares. We want one of them to be a perfect square. So like I said, 4, 9, 16, 25, 36, any of the perfect squares, so that we can take the square root of it. So if we look at the square root of 192, we might say, well, that could be the square root of 4 times the square root of 48. And then we say, okay, the square root of 4 is 2, and then 2 times the square root of 48. But this will maybe answer a question you might have. How do we know we're done simplifying? Well, if this can be simplified anymore, then you're not done yet. Can we split this into factors that will that one of them will be a perfect square? Well, yes, we could do this as 2 times the square root of 4 again. This is a factor of 4 times the square root of 12. So then the square root of 4 is 2. So we have 2 times 2. 2 times 2 is 4. So now that is 4 times the square root of 12. Okay, can we simplify the square root of 12 anymore? Sure, you can make that 4 times the square root of 4 times the square root of 3. Okay, and 4 times, now this is 2, the square root of 4 is 2. 4 times 2 is 8. So now we have 8 times the square root of 3. Okay, well that was a lot of work. And we can see we can't simplify the square root of 3 anymore. It was a lot of work. Okay, so the fastest thing you could possibly do is see what the largest perfect square is that goes into 192. So let's do this a little faster. Let's split this up into 2 square roots and get this to be the biggest square root you could possibly do. So let's bring up our calculator. We'll just see, we'll just go through the perfect squares and see what the biggest one is that goes into 192. So 192 divided by 4, of course, we know that'll work. Okay. How about 192 divided by, okay, so 4, what about 9? Okay, that's not going to work. 192, let's divide it by 16. It is divisible by 16. What about 192 divided by 25? No. 36? No. Let's just jump up to 64. 64 does go into 192. 192 divided by 64 is 3. So we could make this 64 times 3. And the square root of 64 is 8. So the fastest way you could do this is to find the largest perfect square that goes into this. But as I've shown you here, you don't have to do it that way either. You can just keep breaking apart this thing that's left, if possible, and simplify it little by little. So there's definitely more than one way to skin a square root. Number 8. That's supposed to be a 5. 5 times the square root of 24 times 3 root 10. That's how we say that. So before we try and simplify this, why don't we make sure that we have everything together. All right, so we can do 5 times 3, that's 15. And the square root of 24 times the square root of 10 would be the square root of 240. All right. So now let's see if we can simplify the square root of 240. So why don't we pull out our calculator and see, is 240 divisible by 4? Of course, 60. Okay. Is 240 divisible by, oh, we didn't, 240, is that divisible by, okay. Maybe by 36? No, 240 divided by 25, no. 16. Let's go with that. Let's go with 16. That's a pretty big one. So 16 times 15 is 240. So you got the 15 here, times the square root of 16 times the square root of 15. Square root of 16 is 4, so 15 times 4, that's 60. Alright, so we could try and simplify the square root of 15. Well, that just breaks down into 5 times 3. Neither one of those is perfect squares, and that's the only way to break it up besides 1 and 15. And if that worked, then we would just be able to take the square root of 15. So, no, it's not simplifiable any further. So we'll stop there. All right, number 10. Now we've got fractions. The square root of 35 over 36. So we can use this property, just the square root of the numerator over the square root of the denominator. 35 you're going to find pretty easily. You're not going to be able to factor this into anything else that is a perfect square. You got 5 times 7, and both of those are primes, so there's no other way to factor 35. And 5 and 7, neither one of them are perfect squares. So you get the square root of 35 in the numerator. Square root of 36 is 6, and there you go. So that's as simplified as can be. All right, 11. 11 is an example of what you saw maybe in the intro video of something I said was improper. Now this is correct. This is a number, and the number that we get in the end is going to be the same. It's going to be equal to this number. It's just going to be proper. Okay. So how to make it proper? The improperness of this thing is that we have a square root in the denominator, a square root of a not perfect square. We're still left with a square root symbol down here. And the short story of this, the reason why we don't like this is because in the days before calculators, the most advanced thing we had was a slide rule. And this thing called a slide rule didn't have the capability of dividing by irrational numbers like the square root of 3, so we needed to change it up a little bit. So, and it's pretty clever. We're going to multiply this by 1, right? If you multiply a number by 1, nothing has changed. We're going to multiply it by this form of 1. Any number divided by itself is 1, so that's fine. So in the numerator, we'll get 8 times the square root of 3. What do we get down here? We get the square root of 3 times the square root of 3. So we could do the square root of 3 times 3. That's the square root of 9. And the square root of 9 is 3. Okay, so you multiply a square root by itself, you just get whatever's under the square root as the result. Okay, that's called rationalizing the denominator. So let's throw that into the mix of a simplification problem. Number 14. Square root of 13 over 28. So we'll split it apart. Square root of 13 over the square root of 28. I'm not going to be able to simplify the square root of 13, but maybe the square root of 28 you could. We've already done that one actually in one of the previous examples. It's the square root of 4 times the square root of 7. Let's get the square root of 13 still. Then we got 2 root 7. And we can't simplify this anymore, and we don't like Not that you can't have a square root in the denominator, but we don't like it as a math tradition. So we'll multiply by the square root of 7 so that the square root of 7s will cancel each other out, and we'll just be left with 7. So the square root of 13 times the square root of 7 will give us the square root of 91. Right, 13 times 7 will be 91. And we have 2 times the square root of 7 times the square root of 7. Square root of 7 times the square root of 7 is 7. 2 times 7, so we have the square root of 91 over 14. And now that we don't have a square root in the denominator, we like that. Maybe some of us more than others. Some of us don't care. I kind of don't care, actually. But let's move on to number 22 and actually solving some equations. How about this one? Here's a tricky one. S squared equals 169. Okay, so some number s times itself equals 169. So if we just take the square root of both sides, the square root of s squared is just be s, and the square root of 169. What's a number times itself? That gives you 169. Do a little searching. Wouldn't take long. Let's pull out the calculator. 169. Take the square root. 13. Okay. The only thing is, not only is 13 times 13 equal to 169, but so is negative 13 times negative 13, positive 169. So we always say, when we're solving an equation, we actually, like, square root isn't part of the problem to start with, and we introduce the square root, then we would have to say, well, the number that will multiply by itself to give 169, I'm going to have to tell you positive and negative. So we always put plus or minus when we are solving an equation, and we say, let's take the square root. All right. Let's do number 25. Get 6z squared equals 150. All right. Now we want it to be set up like this one was. We want to take the square root of the variable squared. So we'll divide both sides by 6 first. So you get z squared equals 150 divided by 6 is 25. Then we take the square root of both sides. That's just going to give us a z on this side. And the square root of 25 is going to be plus or minus 5. Right. 28 is 7r squared minus 10 equals 25. So again, we want it to be set up just like it was at 22, or in number 22, having the variable squared by itself on one side. That's it. So we'll want to add 10 to both sides. We get 7r squared equals 35, and divide by 7 on both sides. And r squared is equal to 5. 35 divided by 7 is 5. Take the square root of both sides. So r is equal to, always plus or minus is going to be the first thing we write down. And what's the square root of 5? It's just the square root of 5. There is no nicer number. It's just the square root of 5. Number 31. Here's something interesting. Equals 8. All right. So we want this to be set up like it was in number 22, only it doesn't have to be just the variable squared, just something squared, right, with the variable in it. Let me show you what I mean. What if we divide by 4 on both sides? X minus 1 squared equals 2. Okay, so now if this were just x minus 1 equals 2, we could add 1 to both sides and everything would be great. Well, we could get this to be x minus 1 if we just take the square root of it. The square root, we'll take the square root of both sides. The square root of a number is just something times itself that gives you this number. And x minus 1 times x minus 1 gives you x minus 1 squared. So the square root of x minus 1 squared is x minus 1. Another way to look at it, the square root and the square here cancel each other out. So x minus 1 equals plus or minus the square root of 2. And then we'll add 1 to both sides. And we'll get x is equal to 1 plus or minus the square root of 2. Okay, this represents two different numbers. One number is 1 plus the square root of 2, okay? And then the other number is 1 minus the square root of 2. So this represents two separate answers. Two separate but equally valid answers. And that is all. So I hope you found that helpful. Thanks for watching.